So in our last video, what we did is a lot of examples with long division. And long division always works when we're dividing polynomials, but on occasion, we can also do a shortcut, which is called synthetic division. So synthetic division is synthetic, if you think about it in English, it means fake or false. So this is like a fake division. We make it work so that it can shorten things up for us. And essentially what it does is it eliminates the need for all of the intermediary work that you see here. So it's a lot less writing. All of the calculations that you do are the same, but the amount of writing that you're doing is much, much shorter. Okay, so let's do some examples. And what I'm going to do is I'm going to take the first example that we did for long division, and we're going to do exactly the same thing using synthetic division. So let's take x cubed. And first what I'll tell you is for synthetic division, you can only use it if you have a linear divisor. Linear divisor meaning it's got to be in the form x minus a. Okay, so the first example that we had was x cubed minus 3x squared minus 10x plus 24. And we can use synthetic division here because we were dividing by x minus 2. Okay. So let's take a look at what we did with long division. So remember our first step, we always need to check if the divisor and dividend are in standard form. If they're not, you need to put them in standard form. That doesn't change. So when we did this using long division, we wrote the dividend, which is in standard form, so we don't have to put in any placeholders. That went underneath our division bar. And on the outside, x minus 2, which will always be in standard form because we're saying we can only divide when it's in the form x minus a. And x minus a has an exponent of 1 for the x and an exponent of 0 for the a because it's a x to the 0. Remember, x to the 0 is 1, so we don't really need it. Okay. So we're going to do this simultaneously as we do the synthetic division. So I'll do the long division on top and the synthetic division on bottom. Okay, the difference when we set up the synthetic division is we have synthetic division has 3 rows to it. In the first row, you're going to put your divisor, but instead of putting x minus 2, you're only going to put this a value, okay? Think of it as if x minus 2 is a factor, then what would be the root? And if you remember, x minus 2, if it were a factor of some quadratic, we would have set it equal to 0. So the root would be 2. So what you're doing is you're taking the opposite of what you see here. You see a minus 2 in here, you're going to put a positive 2. If you saw a positive 2, then in this box you would put a negative 2. So here we flip it, it's x minus 2. So in our box we're going to put a positive 2. So our divisor goes in the box, okay? Then in the top row, we're going to put the coefficients of the dividend. Okay, so I'm just going to put this off to the side here. In the box, you put your divisor, but when you put your divisor, that's your A value. Then in the second row, in the first row, you're going to put the coefficients of your dividend. So our dividend, the coefficients, coefficient of x cubed is 1. Coefficient of negative 3x squared is negative 3. Coefficient of negative 10x is negative 10. And the coefficient of 24, x to the 0, is 24. Okay. Now, I told you that synthetic division has 3 rows, so just that you know, the second row is going to represent all of the intermediary work. Essentially, that's what we're going to write down here. Okay? And then the last row gives you the coefficients of the quotient, along with the remainder. So we get the coefficients of the quotient first, and then the remainder is the last thing that we get. Sorry, I ran out of room. And somehow this got thicker. Coefficients of the quotient and the remainder. Okay. Okay, so let's do this simultaneously. If you remember, our first question is, how many times does x go into x cubed? And we said x goes into x cubed, x squared times. So I want you to notice something. This is our quotient, and the first coefficient of the quotient is the same as the first coefficient of the dividend. That will actually always be true. If this had been a 2, then we would have been saying 2x squared. So since the coefficient matches, okay, the coefficient of the dividend and the coefficient of the quotient match, what we can do is we can actually just bring down the 1 here. So in our synthetic division, this 1 is just brought down. And we're going to do this a lot, so if you're having trouble understanding what's going on right now, just wait for another example too, okay? Okay, the next thing that we did is we took this x squared and we multiplied it by the divisor. So we did this x squared times x, which was the x cubed, and then x squared times negative 2, which gave us negative 2 x squared. Okay, and that's exactly what we do here. We take our quotient and we multiply by the divisor. Okay, so quotient times divisor. So first we figured out how many times it goes in, and we said 1 time, we said x squared times where the coefficient was 1, so we're carrying down the 1 here, and then we're gonna multiply. So we take the quotient and we multiply by the divisor. Well, here's the coefficient of the quotient. Here's what represents the divisor. We multiply. So we get a 2. Okay. So the next thing that we did is we subtracted. We took this whole thing and we subtracted it. And we got negative 3 minus negative 2, which gave us a negative x squared. Well, here it's the same thing, right? Except the difference is that instead of subtracting, we're going to add. And the reason why we're adding is, notice that here, this x squared gets multiplied by negative 2. Down here, we're using a positive 2. So instead of subtracting, we add down here. Okay, so -3 plus 2, notice we get the same answer, we get a -1. And once again, we're using the fact, now here in this one, we have to bring down. We don't have to bring down anything in synthetic division. Okay, here we divide, we multiply, we subtract, and we bring down. For a synthetic division, we bring down the first coefficient, but then we never have to do it again. Then we multiply, just like we do above. And instead of subtracting, we add. Now here, once we bring down, we go back to the dividing. Here, once we add, we never have to actually divide, we just multiply, okay? Because what happens here is we say, how many times does x go into -x squared? Right? We're looking at the first coefficient, at the first term. X goes into -x squared, -x times. Notice once again, the coefficient here matches the coefficient down here, okay? So we're using this coefficient to multiply. So once again, we have the same coefficient because they match. We're going to take this and we're going to multiply just like we take this and we multiply because we're saying these coefficients are the same, and that's because we're dividing by x. Okay, if we were dividing by 2x, this wouldn't work. That's why we say it has to be in the form x minus a. Okay, so the idea is that our coefficients are always going to match in our intermediary work. So this is -1, this is -1. That means that this -1 is getting multiplied by the 2 because this -1 is being multiplied by the divisor. So when we multiply, in the long division, we would get -x squared plus 2x. And then we subtract this whole thing. And if we do that, this cancels, and we do -2 minus 2, which gives us, -10 minus 2, which gives us -12. Now, if you notice here, we multiplied, so let's do the same thing at the bottom. -1 times 2 gives us -2. Up here, we subtracted, but because we're not multiplying by negative, we're multiplying by positive, we add instead. So -10 plus -2 is -12. So let's keep going. How many times does x go into -12x? So we said x, again, oh, I'm sorry, we forgot to bring down, right? So on top, we have to bring down. On bottom, in the synthetic division, we don't have to worry about that. So x goes into -12x, -12 times. So once again, notice that the coefficients match, okay? Coefficients match because we're just taking away 1x each time. So we had a coefficient of 1, a coefficient of -1, a coefficient of -12. 1, -1, -12. Down here, 1, -1, -12. Okay? So then we take this -12 and we multiply. So -12 times x minus 2 gives us -12x plus 24. And then we will be subtracting this. So the same thing down here. we do our negative 12, so our quotient times our divisor. And our quotient times our divisor gives us negative 24. So notice on the top we get a positive 24. On the bottom we get a negative 24. That's because on the top we're multiplying by negative 2. On the bottom we're multiplying by positive 2. Over here we subtract. When we subtract these on bottom, the negative 12x goes away, and the 24 actually goes away too, and we get 0. Okay, and if you remember, this 0 is our remainder. Okay, on bottom, when we add, we get 0. This 0 represents our remainder. So our remainder is always the last number. Remember, a remainder of 0 tells us that that it's a factor. Okay. So if you notice, you get the same answer because these are the coefficients of the quotient. So in order to turn this into an actual real quotient, not just the coefficients, we put in the powers of x. So that last number is the remainder. The number that comes before it is like your x to the 0. So then you have x to the first, x to the second. Okay, and if there's no number, no sign in front of it, it just means it's a plus sign. So now we can write out our answer. So we said the way that we write our answer is we take the dividend, x cubed minus 3x minus 3x squared minus 10x plus 24. That's equal to x minus 2, that was our divisor, times our quotient. So these are the coefficients of our quotient. So then we put in the x, and we have x squared minus x minus 12. And our remainder was 0, so we don't have to write a plus 0. Okay. So this is synthetic division. So let's just do a bunch of examples. We already did many with long division, so let's just do synthetic. Let's take 2x cubed minus 4x squared plus x minus 2, and we will divide by x plus 3. So we're only going to do, this is a 3, we're only going to do synthetic division. So remember, we have a box now instead of that division bar. And inside that box, this is an x plus 3. So inside, we're going to put the opposite. We're going to put a minus 3. That's our a value. X plus 3 is the same thing as x minus negative 3. So the negative 3 is the a. Okay, you just flip the sign. Then in the top, we put the coefficients of the dividend. So remember, check to see that it's in standard form. So it is. We have 3, 2, 1, 0. So our coefficients are 2, negative 4, 1. If there is no coefficient, it's a 1. Negative 2. Now we're going to take the 2 and we're going to carry it down. Remember, we bring down first. That's because when we divide, we're saying how many times does x go into 2x cubed? Think about what the quotient would be. In the quotient, we we would be putting 2x squared, okay? So the coefficient in the quotient is the same. So we get a 2 here. Now our next step is to take the quotient and multiply by the divisor. So we're going to take this 2 and we're going to multiply by the negative 3. So this row will always get multiplied by the divisor. Okay, so 2 times negative 3 is negative 6. Now what do we do? Well, in the long division, we would have been subtracting. So in our synthetic division, since we're dealing with negative 3 instead of positive 3, we add. So negative 4 and negative 6 is negative 10. Be very, very careful with your addition because this is where mistakes are made. And once you make a mistake, you can't, everything after it is going to be incorrect. Okay? So now we're going to take the negative 10 and we're going to multiply by negative 3. Okay, so we take the quotient, we multiply by the divisor. Negative 10 times negative 3 is positive 30. And then we just add. So 30 plus 1 is 31. Now we take the 31 and we multiply it by the negative 3. And that gives us negative 93. Okay, and then we just add. So I'm going to put this last number in blue because if you remember, that last number, which in this case is negative 95, this is our remainder. So this tells us x plus 3 is not a factor, okay? And now we just fill in our x. So the first one, we go backwards. The first one doesn't need an x because it's x to the 0. Then we have an x to the first and then an x squared. Since we don't see any operation between the 10x and the 31, we could just put a plus sign. So this is our quotient. Okay, so you can see it's much less writing. It's much shorter. This is super beneficial if you have like an x to the 5th or an x to the 20th even. Imagine doing long division where synthetic division, it's still a lot of work, but it's much more doable. Okay, so don't forget to write your final answer. It would be 2x cubed minus 4x squared plus x minus 2 is equal to your divisor times your quotient plus your remainder. So if we multiplied these together and then we subtracted 95, this is what we would get. Let's take another example. Let's say that we had 3x cubed minus 2x squared plus 2, and let's divide by x plus 2. Okay, so once again, we're going to put our divisor in, but we flip the sign, so we're going to put in a negative 2. Then we look at our numerator, our dividend, and we say, is it in standard form? So this is not in standard form. We see 3, 2, 0. We're missing the 1. So remember, it's coefficients. So if there is no x to some power, we put in a placeholder of 0. So this becomes 3, negative 2. There is no x to the first, so we put in a 0 and then a 2. So this 0 represents our x to the first. It's just a placeholder. If you don't have the placeholder, you won't get the right answer. So I want you to notice something. Your final coefficients, your final quotient is always in standard form, okay? We have 2, 1, 0. If you missed this 0, you would not get that, okay? It would not be in standard form. Also notice the degree of the quotient is always 1 less than the degree of the dividend. So the degree of our quotient is 2, the degree of our dividend is 3. Over here, it turns out it's the same thing, but the degree of the quotient, the degree of the dividend is 3, the degree of the quotient is 2. Okay, so let's just put that in. We could put it in up here. I'll put it in down here. So the degree of the quotient is always, because one less than the degree of the dividend. And the reason for that is that we're just dividing by an x, okay? If we were dividing by an x squared and using long division, then the degree of the quotient would be 2 less than the degree of the dividend. If we were dividing by x cubed, then the degree of the quotient would be 3 less than the degree of the dividend. Okay, so this, it will always be 1 less. And it's important to know that because that'll tell you if you made a mistake and you missed a placeholder somewhere. So let's go back to the problem that we were working on. So we put in our coefficients of the dividend in standard form. First thing that we do is we carry down the 3. I can just leave it as the same color here. So the 3 gets carried down. Okay, and now the next thing that we do in long division is we multiply the quotient and the divisor. So this row gets multiplied. 3 times -2 is -6. And then we're adding. We add the 2 rows. We're adding instead of subtracting because we reversed the sign here. We would have been dividing by x plus 2. Now we're doing a -2. So -2 and 6 is, -2 and -6, our negative didn't come out. -2 and -6 is -8. And now once again, we multiply. So -8 times -2 is +16. 0 plus 16 is 16. And then we have 16 times -2. Here's our 16. We multiply it by the -2. We get -32. So notice our work goes into that second row. And once again, the negative didn't come out. Okay, so now what? Now we're at our last number. So that's our remainder, that last number. So 2 and -32 gives us -30. This is our remainder. And then we could just put in our values of x. So we start at x to the 0. We don't have to put in that x to the 0 because x to the 0 is just 1. Then we have x, and then we have x squared. When there's no operation, we just put a plus sign. Okay, and notice the degree of the quotient is 1 less than the degree of the dividend. Okay, you should always check for that to make sure you didn't make a mistake and forget a placeholder. Okay, so that means, again, always write out your answer. Don't leave it like this. This is not enough. 3x cubed minus 2x squared plus 2. Notice when we write our answer, we don't have to write it in standard form. We can just write it as we see it. Is equal to x plus 2 times 3x squared minus 8x plus 16. That's our quotient. And then plus our remainder. Let's do another one. We'll do two more. Let's do 4x to the 5th plus 3x squared minus 2x. And let's divide by x minus, we'll keep the numbers easy. Let's divide by x minus 1 this time. Okay, so once again, we're going to set it up. So inside this box, we put our divisor, but we switch the sign. So this goes a 1, okay? Then we have to check that this is in standard form. Excuse me. If we look at this, we see 5, 2, 1. That's not in standard form. So we have an x to the 5th with the coefficient of 4. X to the 4th is missing, so we need a 0. X to the 3rd is also missing, so we need a 0. X squared has a coefficient of 3. X to the 1st has a coefficient of negative 2. And then x to the 0 is also missing. So we need a 0. Okay, so this 0 comes from x to the 4th, because there isn't any. This 0 comes from x cubed, because there isn't any. And this 0 comes from x to the 0, because there isn't any. And now all we're going to do is exactly what we did before. We're going to start by carrying down that 4. Because 4x to the 5th divided by x is going to give us 4x to the 4th. So we get 4. And then we take our quotient and we multiply by our divisor, which gives us a 4. And then we add the first and the second row. So 0 plus 4 is 4. Now we keep going. We take this 4 and we multiply it by the 1. So 4 times 1 is 4 again. And then we just add 0 and 4 is 1, is 4. Sorry about that. 0 and 4 is 4. And then we do the same thing. 4 times 1 is 4. And then once again, we take these and we add. So 3 plus 4 is 7. 7 times 1 is 7. And then we add negative 2 and 7. Negative 2 and 7 is 5. We multiply. 5 times 1 is 5. And then we said that this last one represents our remainder, which is why I'm putting it in blue. So we get 5. And now what we could do is we could put in our powers of x. So down here, we start with x to the 0. We don't need an x to the 0, so we just write x to the 1st next to the 7, x squared next to the 4, then x cubed, and then x to the 5th. And there were no operations, so these are just all positive. And this is our quotient. And notice the degree of the quotient is, sorry, I wrote x to the 5th, but it's x to the 4th, right? And how did I know that it's x to the 4th? I knew right away when I started checking the degree. When I started checking the degree, this has a degree of 5, so this should have a degree of 4. And I can see that the only mistake I made was just that I wrote a 5 instead of a 4. And then we write out our answer. So we have 4x to the 5th plus 3x squared minus 2x is equal to x minus 1 times 4x to the 4th plus 4x cubed plus 4x squared plus 7x plus 5. And then we have a remainder of 5. Okay, let's do one last one. At this point, you should definitely pause the video and try and do it yourself, because you should be able to do it yourself. I will also point out that I will never require you to use synthetic division, but in our next few videos, you're going to see that it can be really helpful to know it, because it does make things much faster. Okay, so let's say that we have, let's do an x to the 6th just for fun. Let's do 6x to the 6th minus 2x to the 5th plus 3x cubed minus 2x plus 1. And let's divide by x minus 2. Okay, so we're going to set this up inside here. We put a 2. So remember, it's the opposite of what we see down here. So at this point, pause. Do it yourself. Okay, so then in the top, we put our coefficients. So double check. This is 6, 4, 3, 1, 0. That's not in order. Okay, we're skipping numbers. So we have a 6 from the x to the 6th. There is no x to the 5th, so we have to put a 0. Then we have a negative 2 from x to the 4th. A 3 from x cubed. There is no x squared, so we need a 0. Then we have negative 2 from x to the 1st. And 1 from x to the 0. So now this is 6x to the 5th, 6x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, x to the 0. So now we have it in standard form. Okay. First thing that we do, we carry down the 6. Then we're going to be multiplying. Bottom row gets multiplied by the divisor. So 6 times 2 is 12. And then we add the 2 rows. So 0 and 12 is 12. Then we have 12 times 2. Okay, bottom row times the divisor. 12 times 2 is 24. Then we add negative 2 and 24 is 22. And sometimes these numbers can get very big. That's okay. Then we multiply. 22 times 2 is 44. Then we add. 3 plus 44 is 47. Notice we're just repeating the same thing over and over again. We multiply. So we multiply, we add. We multiply, we add. We multiply, we add. We're multiplying. 47 times 2 is 94. And when we add, we get 94. Then we multiply. 94 times 2 is 188. Then we add. 188 and negative 2 is 186. And then once again, we multiply. And 186 times 2 is 372. And our final addition gives us our remainder. 372 and 1 is 373. That's our remainder. And I don't really have enough room to put in the axis here, but I'll put it underneath. So we have x to the 0 with the 186, so we don't have to write that. Then we have 94x, that one I could fit. Then we have 47x squared, 22x cubed, 12x to the 4th, and 6x to the 5th. And notice the exponent, the degree of the quotient is 1 less than the degree of the dividend. And then we just write out our answer. So notice you can't be lazy. You got to write out that answer. So 6x to the 6th minus 2x to the 4th plus 3x cubed minus 2x plus 1 is equal to your divisor, x minus 2, times your quotient, 6x to the 5th plus 12x to the 4th plus 22x cubed plus 47x squared plus 94x plus 186, and then plus our remainder, which is 373. Okay, so just two more brief things that I want to introduce you to that's related, and that's the remainder and the factor theorem. Okay, so I'm going to write it and then I'm going to explain it because I think it's going to make more sense. Okay, so the remainder and the factor theorem are essentially the same thing. Okay. So the remainder theorem says the remainder of a polynomial which we'll call f of x because it's a polynomial function, when we divide by a linear divisor. And our linear divisor has to be in the form of x minus a. Is f of a. Okay, I'm going to write down the factor theorem too, and then you'll see that this is, then we'll go through and talk about what it means. So the factor theorem says a polynomial, again, we'll call it f of x, has a factor x minus a if and only if, sometimes you'll see that abbreviated with IFF if you've ever done logic before. If and only if f of a is equal to 0. Okay, so what does this say? This says, the remainder theorem says, that if we take, let's say, 2x cubed minus 4x squared plus x minus 2, and we divide by x plus 3, what we can do is we could say, okay, what if the only thing that we care about is the remainder? We don't care about the quotient. We could find the remainder just by plugging in this negative 3. If we plug negative 3 into this polynomial, then we get the remainder, negative 95. This says if we plug in negative 2 into this polynomial, then we're going to get the remainder, negative 30, and that tells us what the remainder is when we divide by x plus 2. The next one says, if we have 4x to the 5th plus 3x squared minus 2x, and we're dividing by x minus 1, and all we care about is the remainder, then the only thing that we have to do is plug in 1. Here, for this one, if the only thing that we care about is the remainder when dividing by x minus 2, all we have to do is plug in 2. Okay, so let's actually do this and show you how it works. And then we'll take a couple of minutes and we'll prove it. okay? Before we do that, the factor theorem is going to say, okay, well, if you plug it in and you get 0, then this divisor is a factor. So for example, in the one that we did at the very beginning, we're saying, okay, if we take x cubed minus 3x squared minus 10x plus 24, and we plug in 2 with the idea that we're dividing by x minus 2, you're going to see that we're going to get 0. And the factor theorem says, okay, well, you got 0. That means x minus 2 is a factor, meaning you're multiplying it with just another polynomial, and you don't need a remainder. You don't need to add or subtract anything. You get your dividend. Okay, so let's do this with a couple of them, and just so that you see how it works. So let's start with this x cubed minus 3x squared minus 10x plus 24, and find the remainder when we divide by x minus 2. So you can always find the remainder by doing synthetic division, but this is actually a much easier process. So let's take that first example again. X cubed minus 3x squared minus 10x plus 24. Okay, and we're going to divide by x minus 2. So by the remainder theorem, so if it says find the remainder using the remainder theorem, then you have to do it this way. Okay, so using the remainder theorem. What we're doing is we're plugging in f of 2. Okay, where x cubed minus 3x squared minus 10x plus 24 is your f of x. So we're going to do 2 cubed minus 3 times 2 squared minus 10 times 2 plus 24. Now, some of you are making mistakes here. I saw it when you do average rate of change. I've seen mistakes like this. So 2 cubed is 8. Order of operations. This 2 has to get squared before you multiply by 3. Exponents comes before multiplication. So we have minus 3 times 4 minus 20 plus 24. So 8 minus 12 minus 20 plus 24 is in fact 0. Factor theorem says the remainder is 0. So x minus 2 is the factor. In the second example, if we say f of x is equal to, let's take 3x cubed minus 2x squared plus 2. Okay. We're dividing by x plus 2. So we already did this problem. If we look on the previous page, we did it up here. We should get negative 30. Okay, so let's double check and make sure that we do actually get negative 30. So we're plugging in f of negative 2. Remember, your a is the opposite. So f of negative 2 gives us 3 times negative 2 cubed minus 2 times negative 2 squared plus 2. Negative 2 cubed is negative 8, so it's 3 times negative 8. Order of operations, exponents comes first. Minus 2 times positive 4. Okay, you're squaring the negative 2. A negative number squared turns out positive. And then we're adding 2. So we get negative 24 minus 8 plus 2, which does in fact give us 30. So the remainder theorem says this is the remainder. The factor theorem would tell us this is not a factor. So x plus 2 is not a factor of f of x because, sorry, this is a negative 30. Because f of negative 2 is not equal to 0. Let's take one more. So using the remainder theorem, let's do a different one. Let's do one that we haven't done before. F of x equals, let's take 2x cubed minus 4x plus 7. Let's divide by x minus 4. Okay, so the remainder theorem says we're looking for f of 4. 2 times 4 cubed minus 4 times 4 plus 7. Remember, you do the 4 cubed first. So this becomes 2 times 64 minus 16 plus 7. 2 times 64 is 128. Minus 16 plus 7, and that gives us 119. The remainder theorem says 119 is the remainder. The factor theorem says x minus 4 is not a factor because f of 4 is not equal to 0. Okay, in the last 3 minutes, let's prove the remainder theorem. It's a very simple proof. It's not necessarily intuitive though, which is why I'm not asking you to do it on your own. I'm going to walk you through this one. So we're saying that the remainder of f of x is f of a. So I want you to think about how we write the answer to f of x. The answer to f of x is our divisor times our quotient plus our remainder. Okay. Now in the remainder theorem, what we're saying is that our divisor is just x minus a. Okay. The remainder theorem says if we plug in a, then we get the remainder. So let's plug in a. That means we're replacing every x with an a. Now we don't know what our quotient is, so we can't replace. And the same thing is true of the remainder. We don't know what the remainder is. But here's the thing. A minus a, which is what we see here, is just 0. So we have 0 times the quotient plus the remainder. But think about it. What is 0 times the quotient? It doesn't matter what the quotient is, okay? 0 times the quotient gives us 0. And here's our proof. If f of a is equal to 0 plus the remainder, then f of a is just equal to the remainder. We just proved it. So what we did is, in the remainder theorem, f of x divided by x minus a gives a remainder of f of a. So here, x minus a is the divisor. So we replace the divisor with x minus a. And here, we plugged in x equals a. And it didn't matter what the quotient comes out to be when you plug in x equals a, because 0 times whatever it comes out to be is 0. So we proved the remainder theorem. F of a is always going to equal the remainder. Okay, that's it for today.